In this video, we're diving into the world of C++ type conversion. Type conversion, also known as typecasting, is the process of converting a value from one data type to another. We'll explore how to convert data between different types, which is a fundamental concept in C++ programming. We'll look at two main types of conversions: implicit and explicit. Implicit conversion refers to automatic type conversion performed by the compiler without explicit programmer intervention. Explicit conversion refers to manual type conversion using casting operators to convert data from one type to another. Let's begin with implicit type conversion, also known as automatic type conversion. The compiler automatically converts one data type to another under certain conditions. This happens when different data types are used in an expression, or when data is assigned to a variable of a different type. For example, consider the code snippet. We have an integer variable number_int initialized to 9, and a double variable number_double initialized to 5.5. When we add these two variables, the integer is implicitly converted to a double so that the addition can be performed. The result is a double 14.5. Then, there is an implicit conversion from double to integer. When we assign the double variable result to an integer variable truncated, the decimal part is truncated, resulting in truncated being equal to 14. C++ follows a specific hierarchy when performing implicit type conversions. This hierarchy determines how different data types are promoted or demoted. Starting with safe conversions. A bool converts to an int, which converts to a float, which finally converts to a double. This direction is considered a safe conversion with no data loss, also known as widening. Also, converting a char to an int is a safe conversion. But potentially unsafe conversions exist as well. Double to float to int to bool conversions can lead to precision loss or truncation. Similarly, converting an int to a char can result in data loss if the integer value exceeds the character range. Key points to remember are that smaller types are generally promoted to larger types, sign types may convert to unsigned types, floating point to integer conversions truncate the decimal portion, and any non-zero value converts to true, while zero converts to false. Now let's explore explicit type conversion, also known as casting. This involves manually converting a value from one type to another using casting operators. There are a few ways to do this. First, we have C-style casting, which is a traditional method inherited from the C language. For example, consider the code. We have a double variable pi initialized to 3.14159. To convert this to an integer, we use C-style casting by placing int in parentheses before the variable pi. The result is an integer int pi equal to 3. Alternatively, we can use function-style casting, which is an alternative syntax for type conversion. In this case, we write int in parentheses, followed by the variable to be converted, value. The result is the integer rounded equal to 9. Modern C++ offers several casting operators that provide more control and safety compared to C-style casts. First, we have static cast, which performs compile-time type checking for conversions that are well-defined. This is generally safer than C-style casts. For example, we use static cast to convert the double variable pi to an integer. The syntax is static_cast less than int greater than pi. The result is an integer int pi equal to 3. Next, there is dynamic cast, which is used for safe downcasting in inheritance hierarchies with runtime type checking. This is particularly useful when dealing with polymorphism. As an example, consider base pointer equals new derived. Derived pointer equals dynamic_cast less than derived asterisk greater than base pointer. If the cast is successful, then the derived pointer will point to the derived object. Otherwise, it will be a null pointer. Continuing with modern C++ casting operators. Const cast is used to add or remove the const qualifier from a variable. This can be useful in certain situations, but should be used with caution. For example, we have a constant integer value equal to 10. To modify this constant value, We use const underscore cast to remove the const qualifier from the pointer to value. Then we dereference the pointer and assign it a new value of 20. Reinterpret cast performs low-level reinterpretation of bit patterns. This is highly dangerous and should only be used when absolutely necessary. For instance, we use reinterpret underscore cast to convert a pointer to an integer. The syntax is reinterpret underscore cast less than unit pointer underscore t greater than pointer. This converts the pointer to an integer type that can hold a memory address. In C++, you can also define your own type conversions for user-defined classes. This allows you to control how your classes interact with other types. Conversion constructors allow implicit conversion from another type to your class. A conversion operator allows implicit conversion from your class to another type. For example, consider the conversion constructor. It allows us to create a fraction object from an integer, automatically setting the numerator and denominator. And for conversion operator, it allows us to implicitly convert a fraction object to a double, which can then be used in arithmetic operations. Here are some best practices to keep in mind when working with type conversions in C++. Use modern C++ casts. Prefer static cast and dynamic cast over C-style casts for better type safety and clarity. Be explicit. Make conversions explicit when they might cause data loss or unexpected behavior. Avoid dangerous casts. Use reinterpret cast and const cast only when absolutely necessary, as they can lead to undefined behavior. Consider performance. Be aware that some conversions may have runtime overhead, especially dynamic cast, so use them judiciously. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.